Right, I've borrowed a question from mathsmadeeasy.co.uk. It is a speed time graph representing a car that's accelerating. Now the area under the graph, if I can work out the area under this graph, all of this, the area under the graph represents the total distance traveled. Now, to get the exact area under that graph, it's a little bit awkward, right? Because you've got a curve here, right? What you can do, one way of doing it, remember I'm not answering the question at the moment, I'm ignoring what it says in the question, but to get a rough idea, you can kind of draw a triangle. There's my triangle, and work out the area under that triangle, which is roughly, or very roughly, the area under the black curve. Okay, now that is just a triangle, basic triangle, and you know the area of a basic triangle is base times height divided by 2. The base here is 20 seconds, 20. The height looks like it goes up to 52, 54, 57, and obviously you've got to divide by 2 because it's a triangle. So very roughly, it's 570. And because on the side it says meters per second, that stands for meters, that would obviously be meters as well, right? We have overestimated it. Why? Because the area under that triangle is obviously more than the area under the curve, right? The green bit that I'm shading now is the area under the curve. But the area of the triangle is slightly more than the area under the curve. That's why that value there is an overestimate, all right? Now I'm going to answer the question properly. Reading the question now, below is a speed time graph of a race car accelerating. Using 4 strips of equal width, estimate the distance the car traveled over the course of 20 seconds. What I'm going to do is split the area under the curve into shapes that are known, but it wants 4 strips of equal width. So I need to split that time, 0 to 20 seconds, into 4 equal strips. So that's from 0 to 5, 5 to 10, 10 to 15, and 15 to 20. You can see there's 4 sections there. 1, if you follow the cursor, 2, 3, 4 parts there. Right, so from 0 to 5, if I just draw a shape underneath it, I can see there's a triangle there. Right, that there is a triangle. I'm going to work at the area of that triangle. So let me just label it from 0 to 5. All right, I'm showing the examiner what I'm doing. Between 0 and 5, it's a triangle, so it's base times height divided by 2. The base is 5. Look, 0 to 5, it's 5. The height up to here, the height of that triangle looks like it's 4, and then divide by 2. 5 times 4 is 20, 20 divided by 2 is 10. So the green triangle is 10. So you can say when the car traveled from between 0 and 5 seconds, it traveled only 10 meters. Right, the next thing I'm going to do is work out the area between 5 and 10 seconds. I'm going to draw a shape. Looks like that's a trapezium, right? Because you've got 2 parallel sides. I'm going to work out the area of that trapezium. So tell the examiner exactly what you're doing between 5 and 10. That's the calculation I'm doing. Formula for area of a trapezium, where A and B are the 2 parallel sides, and H is the gap between the 2 parallel sides. So you got half. The A, if you follow my cursor over here, that's got a height of 4. Obviously the same as that. Right, the other side here, the other parallel side's got a length of, looks like it's 10, 12, 14. And the gap between 5 and 10 seconds is obviously 5. The gap between the 2 parallel sides. and obviously that's going to give you 45 meters. Right, next, choose a different color. I'm going to work out between 10 and 15. You can see I've got a trapezium here which will have an area slightly more than what's under the curve, so it will eventually be an overestimate. I'm working out the area over here, so between 10 and 15. But A is going to be obviously whatever was here, 14. Remember this bit over here, if you can see the cursor, that's got a length of 14. Right, the other side, it's got a length of, it looks like 32. And the gap of that trapezium between the two parallel sides is going to be 5. It's got an area of 115 meters. Right, last one. Right, last one over here. I've got, looks like I've got another trapezium. Oh, that line there, it's almost a perfect match to that curve. Go all the way down. So I need to work out the area of this now. Right, you don't need to colour this in the exam. Okay, I'm just doing it for illustration, so I can teach it. Right, again, between 15 and 20, tell the examiner what you're doing. Right, now A is going to be obviously whatever that is, 32. Right, if you follow my cursor here, that's got a height, so that's got a length of 32. And the other side, it goes all the way to 57. And the gap is 5. (222.5 meters). Now, to work at the total area under the graph, and remember it's just an estimate, we need to add these numbers together to get the total area. I'll just do it over here. Total is 10, 45, 115 and 222.5. I get 392.5. Right, yours might be slightly different depending on how you read the graph, but your answer should be around about 390, 392. If there was a part B to this question and he asked, is this answer an underestimate or overestimate? As I've already explained, this is going to be an overestimate, because if you look very carefully, right, so as you can see here, if I just highlight this to you, so this bit over here, right, I didn't really need this bit. This is not area under the curve. Remember what I said, to work out the total distance traveled, you need the area under the curve. I've actually worked out a little bit, just what I'm shading here, just a little bit that's above the graph, right? So I've worked out slightly more than what's necessary. And I had no choice because I had to make a trapezium, and that trapezium, when I drew that trapezium, the top of this trapezium there happened to be slightly above the curve, right? So when I worked out the total area of the trapezium, all of this, right, all the way, everything, right, I've actually worked out an area which is slightly more than what's under the black curve, the area under the black curve. Hence, I've overestimated my answer very slightly. Right, this one's a slightly different curve, right? If I was to split this up into trapezium, let's say 3 equal strips, you can see that triangle there is the area of that triangle is going to be slightly less than the area under the blue curve. Right. If I was asked if the area of the trapeziums, the area of the shape that I just made in red, right, all of this, if it's an underestimate or overestimate, the area of the red part, the red shapes, is clearly an underestimate of the true area under the blue curve. Because you can see here, if I just zoom in, I've not worked about working at the area of the red parts. I've ignored the area, these gaps over here. So you can see these gaps I'm highlighting, yeah? These white gaps there, I've not included those. So clearly the area under the area of the red parts, whatever answer I get, is an underestimate of the true area under the blue curve.